Hello everybody, and welcome to today's presentation, the I/O of DevOps and where a TimeSeries database fits in, brought to you by Influx Data. I'd like to introduce you to our presenters. Larry Gordon is the Chief Revenue Officer at xOps and has held senior leadership positions at Cognizant and Capgemini, and has founded and led IT services and software companies in the security, DevOps, and digital transformation segments. He has also been a successful angel investor in the energy and cloud spaces. We also have Sean Mack. Sean is a visionary technology executive with extensive experience in operations development, quality assurance, program management, and infrastructure. Sean has led global DevOps teams across a wide range of companies, from global financial companies like Experian to innovate tech companies like Etsy. Well, without further ado, I'm going to turn things over to Larry and Sean to begin the presentation.
Thanks. Hi, and welcome to the I/O of DevOps. I'm Larry Gordon.
And I'm Sean Mack.
Hey, Sean.
Larry?
We're going to be talking about data and DevOps today. We'll be looking at how you break down information silos using tools such as InfluxDB and the Tickstack. While we get started, we'll tell you a little bit about ourselves. We are xOps. xOps helps companies run their technology more efficiently and more effectively. We build open source tools and offer a suite of related services to help your business. Our services include DevOps consulting, tool implementation, and outsourced Tier 1 and Tier 2 managed service. As we talked about a little earlier, Sean's our CEO, and I'm our Chief Revenue Officer. A bit of an overview, a bit of a roadmap of where we're going to go. We're going to set up the problem of informational and cultural silos in enterprises and organizations and how to break them down using DevOps processes and sharing information. Now, of course, people don't really DevOps their data, but we're going to be talking about the processes to apply to your data streams in order to build better DevOps organizations and some solutions. Where do we go from here? We'll talk a little bit about some of the solutions we're seeing enterprises implement. I'm going to set the stage a little bit with some metrics and speak to what outages cost. So a study from CA Technologies found that $26.5 billion in revenue is lost each year from IT downtime. And this is just revenue. In fact, revenue is not even the main impact of downtime. Another study found that 78% of downtime costs relate to reduced worker productivity. So with downtime, not only are expensive engineers not able to do their job, but revenue isn't flowing into the company through these revenue producing applications. I'll hand it over now to Sean to speak a little bit about how information silos can negatively impact your availability and what you can do about this problem. Hey, Sean.
Hey, thanks, Larry. So, in DevOps, there's a lot of focus on the deployment pipeline. We take a lot of time talking about the front end of the cycle, on automation, continuous integration, continuous deployment. But the reality is that we're all, well, especially in mid to large size organizations, we're all living with complex engineering landscapes filled with legacy systems, as well as newer systems, and they can't always be in the full CI/CD deployment pipeline, fully tested. The reality is that it's not all perfect, and that there are going to be problems, whether it's with legacy systems or with new systems. And when that happens, when there are problems, we need to be prepared. Now, there's been challenges here, and those challenges are exacerbated by the massive amount of data growth, especially in mid to large size organizations. We see a proliferation of tools where companies may have, 5, 10, upwards of 20, 30 different tools just to monitor their infrastructure. In fact, this survey by App Dynamics showed that 65% of enterprises have 10 or more monitoring tools. In fact, one of the clients that we worked with had over 50 different tools. Now, with that sort of amount of noise, you run into a couple problems. One of those is that there are distinct groups which have access to distinct pieces of information. But also, it's just impossible to really understand how your systems are performing with that amount of different noise coming into the equation. So we're going to take a little time today talking about some of the ways you can approach this massive data proliferation to cut through that noise and get to the actual root cause of the problem. Now, as I mentioned, one of the things that happens here is when you get this data explosion is that certain groups have access to only certain pieces of information. Now, again, in DevOps, we talk a lot about organizational silos, but there's a parallel construct here where data gets siloed. And that can be the typical siloing of data where the developers have access to, the data about, their code performance and code metrics, and the operations only care about how their systems are performing. But we also see this, even sometimes more acutely in the siloing of data between the business users and the technical users, where the business users have insight into things like sales pipeline, into things like the revenue coming through the system, and the tech users can't see that. And the tech users have information into system performance, may even be how users are experiencing the system, and that information isn't available to the business users. And even within traditional operations teams, we often see the siloing data where the network team may be the only ones who get a view into how networks are performing. The database teams are the only ones who see the database, how the database is performing. These sorts of silos create all sorts of problems. I can't tell you how many times I've personally been on critical incident calls where the network team is saying, hey, everything looks fine on our system, and the database team is saying everything looks fine on our system, but everything is clearly not fine. And without sharing this data and breaking out of these information silos, we're trapped into a myopic view of our own systems and not sharing the problem and not sharing the solution. Gene Kim, Jez Humble, and Patrick Dubois talk a bit about this problem in the recent book, the DevOps Handbook. They say, for decades, we have ended up with silos of information where development only creates logging events that are interested to developers, and operations only monitors whether the environments are up or down. So clearly a recognition of this problem. They go on to say, as a result, when inopportune events occur, no one can determine why the entire system is operating as designed. So we're going to talk a little bit about what you do about this. But before I get into a solution, I'll give you an example of one instance where this happened. We were working with one customer who had an outage that impacted 50% of revenue for over 48 hours before anybody even realized. Now, you ask yourself, how can this even happen, right? The fact was, it happened because of information silos. The the finance team only looked at their data, who was getting information that revenue was at 50% of what it should have been, only looked at their information weekly. So they didn't see this despite the fact that the company had just gone into peak season. While the systems team did get alert, it was only on one of a system which they assumed to be redundant. And they assumed that the other system was successfully picking up the workload. But because of the way the system was designed, half of the transactions were still being routed to the bad system, causing a loss of 50% of transactions. And finally, customer service, who was getting deluged by calls from users, was too busy to tie the problem back to the underlying cause, and be unaware of the alerts that the other teams were seeing.
Sean, I totally believe that story. I hear it a lot. It happens all the time. This is not you in the picture. I'm just a fireman. That doesn't look anything like you.
Yeah. I've lost a little weight since then, Larry. Maybe back in the 80s.
All right.
So let's talk about what to do about this problem. There are some key steps to DevOps your data. First, you want to determine the sources of that data and reduce duplication where you can. Secondly, centralize that critical data. And finally, up-level your data to make it more valuable to everybody who's sharing in it. So, the first step of determining your data sources and reducing duplication. So while technical advances in big data and decreasing storage costs have come a long way, there remains a need to evaluate your data sources and remove duplication where possible and where reasonable. Now, that's not to say that you should only have one tool to monitor all of your systems. In fact, I really don't advocate that approach, right? But what that is to say is to identify potential duplicative sources. So going back to this company I worked with that had 50 plus different monitoring tools, they had 5 tools just to monitor CPU, right? So an awesome example of where you could really reduce was right there. In fact, some of those same systems were implemented in different data centers in different ways. So a red alert in one data center would not mean the same thing as a red alert in another data center. And you can have, almost religious battles about whether, Nagios is better than Zabbix or Xenos or the other. Ultimately, it's not about picking, it's about finding what you believe is best in breed for your use case and sticking with that, right? So, and finding where you can eliminate duplicate sources of data is going to be key to making sure you're getting the best data into your correlation and presentation, and find the data of diversity and granularity that's right for your organization. And this is going to depend on the maturity and scale. So for some organizations, a small handful, 2, 3, 4 different tools is going to be the right number. For larger organizations where you might have a more complex technical landscape, might be able to have more depth of knowledge in specific fields, you might want more. In fact, you might want to really choose the best in class for each level of your stack. The best in class cloud monitoring, the best in class network monitoring, the best in class database monitoring, the best in class system monitoring. The point is really not to have 5 different system level monitoring. And if you can reduce that duplication as a starting point, you're really making progress already. Once you've got to that rationalized set of tools and decided the type of data that they're going to be collecting and push to, you want to put all that data in one place. Now, I realize this is easier said than done. There are challenges to make this happen. In fact, a lot of these data collection tools, monitoring tools, were not designed with the priority of sharing that data. This is in part because they were designed to collect that data and present it to you. Their main goal was not to collect the data and share it with other tools. Your financial data data collection agent was first and foremost designed to present that data to your finance team, not to share it with the same tools that are collecting your system data. The other challenge is obviously that there are various types of data. Some data which is highly structured and other data that is spurious and unstructured. And in addition to the technical challenges of centralized data, there are also organizational challenges, sometimes very real legislature challenges where you may not be able to share your revenue data with the company. Where that happens, you may look for proxy like number of orders or something like that. But as much as possible, I strongly advocate sharing as much of the data as you can and pushing it to a central location. So once you've got all this and Influx Data, which Chris will join us to talk about in just a moment, is a great tool for pushing all this data, bringing all this data together and presenting it to your users. Once you've got all this data together, you want to transform it from data to information and then into intelligence. And what I mean by that is really taking this massive data and looking at ways to make it useful for making and leading good decisions for your business, because data alone, a lot of data alone, is not useful. It's really only useful when you transform it into something that can lead you to better decisions, right? There's a few ways to do this. You can look at service maps, advanced algorithms to automatically understand what data relates to what part of your system. There's also a lot of useful ways to aggregate the data and do analysis so it actually pertains to the system health. You can do this by defining what are the components of the overall health of your system, giving weights to various pieces of data, setting thresholds so that you can really correlate the different inputs of data that you're getting to specific system functions. Also make sure you're looking at the customer perspective. Let's not, get too focused on the internal. Taking things like real user monitoring, synthetic monitoring to really get that vantage point of your customer becomes a key piece of input for these sorts of equations. And even social media feeds can be a really good piece of this picture, right? Doing things like marrying up your information from your Twitter feed to get user sentiment and marrying that to information about, system performance from a external vantage point, or even system performance from an internal vantage point, can give you invaluable information about how you're performing to ensure that you're reacting to events as soon as they happen. And once you've got all this data, you can even go beyond that. We are beginning to see advances in machine learning, advanced analytics, where you can begin, once you've got this data coming together, to marry it against information about critical outages, incidents, so that you can actually begin to predict when incidents may occur, take remediation action before that occurs to prevent the issue from ever actually impacting your user. There's a lot of amazing stuff you can do once you begin to break down these informational silos, bring the data together, and share it with your users. I'm going to turn it over to Chris now to talk a little bit about Influx Data, the Tickstack, and one of these great tools you can use to bring all this data together. Chris?
Hi, everybody. My name is Chris Drill, and I work at Influx Data. And I'm just going to talk really briefly about some of our open source projects as it relates to the conversation that we were having with Sean and Larry. And so, I think I think it should be pretty clear by now that in order to make sure that we have, we can break down these data silos, we do need to make sure that we share the responsibility of monitoring across all these solutions with everybody that's either responsible for putting infrastructure up or writing code. And one of the ways that you can do that is allowing everybody that's a part of that to actually monitor, their own component and see how it's impacting the overall solution. And one way you can do that is with the Influx Data Tickstack. And Tickstack is actually our 4 open source projects, and it stands for Telegraph, Influx Data or InfluxDB, Chronograph, and Capacitor. And as I mentioned, they are open source projects written in Go, so it's always a fun excuse to just play around with it, because I know a lot of people are interested in Golang. And because we are targeting the development community, we wanted to make sure that it's really easy to use. And it's not just some marketing hype. We really needed to make sure that anybody who's maybe not previously responsible for monitoring can actually install the Tickstack, get it up and running, and start collecting any kind of metrics as quickly as possible. And some of the key benefits, as you can see here, is it's easy to use. There's no external dependencies. You don't need to have a secondary data store for all this information. We can allow you to collect all kinds of time series data, regardless if it's a metric or an event. And the difference is being that a metric is something that you collect on a regular interval, and an event is usually an anomaly, something that happens at an irregular time interval. The solution is horizontally scalable, and it's a full platform, so it's not just one component of the monitoring stack. And finally, we can also help developers and DevOps personnel to be able to collect time series data or this metric data either by putting a collector agent on a server or a database and be able to pull the metrics, or for more ephemeral things like containers, we can actually do a service discovery and actually grab the metrics that way. Next slide, please. So the other thing that I just want to point out very quickly is that you're not just limited to metrics to collect on your database. And if you think about your overall solution, there are indicators across the board that are going to let you understand whether or not the overall solution is performing or not. So definitely the traditional server metrics, CPU metrics, how well the database is performing, those are all very critical in making sure that your end users are having a pleasant experience with your service. But there are also other metrics that are going to be important. And it could be metrics that you're gathering within just your piece of code that you're writing. So you're just writing a particular function that's allowing somebody to, interact with your solution, and your developer wants to be able to understand, did my piece of code actually have a negative or positive impact against the CPU or the server load? It could also be metrics about the solution itself. So on the top here on the left, you can see one of the metrics that we're listing is IoT metrics. So are you gathering information from various sensors that can then lead to a pleasant or unpleasant experience for your users? And then finally, also, there are a number of business metrics that might be important to help your finance team, as Sean articulated earlier, that could be indicators of, are we having a good or bad impact on revenue? Regardless, the idea is that whatever kind of metrics that you want to gather, you can gather it with this Tickstack. You can get everybody responsible for making sure your solution is performant, participating in it. And then what they can do with it, you can see on the left-hand side, is you can then just do your standard monitoring. You can also use it for analytics to determine, how things are going. You can also use it for tracing, which is, really trying to make sure that you understand where the handoffs are problematic within your code. And then also you can apply some machine learning to it to do some predictive modeling, so you can understand, okay, is it now time to replace that server, or there's some things that we have to change, or is this spike in users good or bad? Is it actually going to be more revenue, or is it actually an indicator that something's about to go sideways? Next slide, please. So just, you may wonder, why do I need a specific platform for time series data? And I've listed some of the key points that are required to make sure that you have a database that is performant when talking about metrics and events or time series data. And if you think about time series data, this is data that's going to get collected on a regular interval. So per minute, per second, per millisecond, even down to the nanosecond. And very quickly, you can see that it's going to be a lot of data. And so being able to ingest a large volume of data is really important when you're thinking about time series data. And that's why that's one of the key things that we focused on when building InfluxDB. At the same time, especially if there's something wrong, you're going to want to be able to query that data. So you have to make sure that this database can focus on those two key elements. Reading in lots of data, at the same time being able to look at that data so you can then do something about it. And then the thing that's interesting about time series data is it's really important to have super high precise data in the near future, or in the near present or in the near future. But then over time, that precision may be not as important. And so one of the other key features in a time series database is the ability to evict data over time, downsample that data over time, because maybe in the future, and the future could be as soon as a month or 6 months, maybe you don't need it down to the second. Maybe you can be able to use that data for forecasting purposes just on a daily basis. And then finally, because it's also, as we mentioned, a lot of data, we also make sure, and all time series database actually have this capability to be able to compact the data so that we're not hoarding all that data in all your data stores. Next slide, please. And this is just another viewpoint of the Tickstack. So you can see on the left-hand side, we have Telegraph, which is our collector agent. We have over 160 plugins that are already built, mostly built by the community, which is great. That's the whole point of open source. You can get a lot of contributions. And you can start collecting data very quickly from databases, your networks, your apps, etc. Alternatively, if you don't want to use a collector agent, you can also write directly into InfluxDB. There's a number of different client libraries that are available. So if your development team wants to start collecting metrics on their JavaScript or their C# or Python code, that can also be done and written into InfluxDB. InfluxDB is the database where you store all that information, and you can do some queries. And some of the queries that you might do is you might want to pull them into a dashboarding product like Grafana, which is super popular. A lot of our customers and users actually have a custom dashboard that they have in their solution, so you can pull it into that. Or you can use Chronograph, which is our interface not only into the data within the database, but you can also do some dashboarding with it as well. And then finally, the K in the Tickstack is capacitor. If you want to then do some processing of that data, you want to actually apply some machine learning algorithms on it to do some predictions on where things are going to go, you can do that. Apply that, output it, bring it back into the time series database, and then set various alerts so that you can make sure that the appropriate workflows get triggered. So these are all open source projects, free to download, and actually quite a joy to use. So I recommend that everyone give it a go.
Great. Thanks so much, Chris. So, as we look at bringing all your data together and finding a solution like Influx to bring this all together, to break down the silos, there are a few things to be wary of that I want to point out here. The first is to stay away from point solutions. By that I mean, and I addressed this a little bit earlier, while you may need something to measure your system performance, try and find a solution that will do that for all your systems, whether you're running Linux, whether you're running Windows, across all of them. This isn't something that can't be generalized. So if I am going to buy a product, say a new network device, I want to make sure that that device can be monitored by, my network tool, my generalized network performance monitoring tool, rather than hearing, oh, well, you've got to monitor this with this specific tool. I actually try and take a similar approach to cloud as well, looking at what tools can I use to monitor a multi-cloud environment. So when I'm looking at tools or looking at other solutions, I try and ensure that I don't get stuck into a solution that only fits one specific point of the problem, because that's going to guarantee tool sprawl. You also want to avoid vendor lock-in. A lot of the correlation and presentation tools will say, hey, we've got this, especially with the larger vendors, the HPs, the IBMs will say, hey, we've got this great tool that can bring all of your information together, but you also have to use our CMDB, or you also have to use our APM solution. So when you're looking at what the right solution is, I love open source because it's generally built with the approach of let's be open and share and be open to working with any other vendors rather than a proprietary lock-in to other tools in the same ecosystem. The other thing I'd say is to be sure you have access to your data when you're investing in any tool. More and more, the newer tools are of this vein where they will have APIs to access your data, but that's not always the case. So whenever you're looking at a new tool to add to your ecosystem to ensure performance of your systems and services, make sure that you have access to the data. And part of that is ensuring you have complete APIs and for automation and interrogation. And I think finally the last thing I want to mention is that you want to build a culture of collaboration. Any tool alone does not make you DevOps, right? You can't say, hey, man, I just DevOps the heck out of my data. That just doesn't work. There are no tools are not in and of themselves DevOps. Tools are non-DevOps tools. I see DevOps as a culture, and you can't say, hey, I have a cultural tool, I have a collaboration tool. Even tools that are specifically designed for collaboration can be used in a non-collaborative way. I've seen organizations where chat tools, which are the kind of by definition one of the best examples of a collaboration tool, and I've seen organizations where they're actually used to further silo information, where the business organization is using Skype to communicate, the operations team is using HipChat, and the development team is using Slack, right? So further ensuring that those teams aren't communicating with a collaboration tool. So the important thing to make sure is that you're building culture from the ground up. You're looking at culture, first instilling a culture of collaboration, and then choosing tools that help you build that collaboration throughout your organization. So to recap and look at where we go from here, what are your next steps? What are your takeaways from what we've discussed? I encourage everybody who's been listening today to look at the services, the applications that they're managing. Look at it from a customer point of view, and look to improve the performance and reliability for your customers. And to that end, you want to identify and reduce any duplicative data. You want to look at your tool selection, make sure you're reducing point solutions, and have really rationalized the decisions, architectural decisions you're making about tools and how they integrate. And finally, determine a central data collection and presentation engine. If you can do these things, you'll go a long way to breaking down these informational silos, making your organization more effective, and making your customers happier. Thank you, and I'll turn it over to Larry to close up.
Great job, Sean. Great job, Chris. Really, really clear. Very, very useful is actually some of the notes I'm getting in. If you are more interested in finding out more information on this topic and other very DevOps related topics, we only work in DevOps. There's a nice group of articles and practical blogs on our website at xops.it. Our Facebook community is XOps Army. Lots of live one-on-one videos with real DevOps practitioners, how to and how they solve problems. And follow us on Twitter at XOps, and we announce our regular meetups and coffee ops and other types of resources for folks to interactively get information on solving these types of problems. So thanks, guys. And I think Chris and DZone have a little bit more to say.
Great, yeah. If we're ready, we can do a little bit of question and answers. We have a few questions here, but if you have any other questions, please post those in the questions panel. First question I have here, in your experience, how do you break down the silos so that alert definitions, etc., will be in sync across organizations?
Sure, I can take that. So, I mean, this is a great question. I think one of the key starting points here is to, at the highest level, ensure you have shared goals and define what those goals are, and make sure that you're not working towards separate ends. Like you talk about the classical division between dev and ops, right? It's driven by conflicting goals, where development is driven by the goal of producing X number of features, and operations is driven by the goal of maximizing availability, maybe performance, right? And that fundamental division of goals almost ensures that the teams are working in opposing directions. When you think about a DevOps culture and aligning metrics and alerts to achieve the same ends, I would really suggest starting at the highest level in terms of what are the goals and making sure everybody is focused on the same goals, and looking at what those are for your organization. Once you have that, the next level and the next level of things that you're measuring about your system, your alerts, are going to line up in that direction, and then you've got your whole organization focused on the same thing in the same direction, and you've broken down those silos a lot already.
Great. We have one more question here for right now. Can organizations take a bottoms-up approach to changing the culture to be more agile/DevOps?
Yeah, so I can jump in here too. Another great question. I think some of the best DevOps transformations I've seen have had a component of a bottoms-up approach. Some have even started with a bottoms-up approach, although I think the most successful ones are ones that are driven from the bottom and the top, right? It's very hard to see a transformation initiative which does not have the support of the executive leadership, that can certainly generate from a grassroots movement that says, hey, we need to do things differently. And also, you know, the other thing I'd say is that there's a huge power to leading by example, and those examples can be very small, right? So if you can find a way to, within, you know, at a grassroots level, build a DevOps team, build a DevOps culture, and show the success of that, the organization will start to follow. That said, it's very important to have both the grassroots approach and buy into the transformation, but also to have the executive level, senior executive level buy-in and push for the organization to truly be successful.
All right. Well, that's all the questions that we have right now. Larry, Sean, or Chris, do you have anything you'd like to say as we start to wrap up?
I'm good for now. Thanks very much.
I am as well.
If I can cut in here, got one more question here. Came in last minute. How many tools are too many tools?
That's a great question. I think whoever's asking that probably knows they have too many but I'll go back to what I said earlier, which is that it's highly dependent on the size and maturity of your organization. On the one hand, if you've got a small organization and you have 20 different tools, and that's more tools than you have people on your team, you've got too many, right? But if you have a huge organization where you're supporting thousands of applications and tens of thousands of nodes across a hybrid environment, you may need I've seen organizations, mid to large sized organizations with, a good 15 tools where that made sense for the size of the organization and the type of specialization and the diversity of the technology footprint. So it's really going to depend. However, that said, what I would look at is, do you have duplication or redundancy, right? Do you have 5 tools just to monitor your network, or 10 tools just to monitor CPU across the organization? Not only does that make your tool footprint more complex and make it harder to get all your data in the same place, but it also just makes it harder to manage. Some of the best technology organizations are the ones that really manage to keep things simple, right? The more you can simplify, the better, because it also means that if you've got a problem in an area you may not be familiar with, you're jumping in there at least with the same set of tools, the same set of technology to manage it, ensuring that you can address and resolve issues that much quicker. So I guess to summarize, I'd just say there isn't a one number that I can give you. It's going to depend, but look at the size and maturity of your organization, and you can.
All right. We have another question that rolled in here. What's your view on the data isolation and security while monitoring ops as a cloud platform vendor versus cloud org owner, and how is xOps managing this?
Sean, do we still have you? Sean?
Oh, I think Sean cut out there a little bit.
Can you hear me now?
We got you now.
Yeah.
Oh, okay.
You got the question, Sean?
Yeah, could you just repeat that quickly?
Yeah.
Sure. What's your view on the data isolation and security while monitoring ops as a cloud platform vendor versus cloud org owner, and how is xOps managing this?
Platform vendor as a cloud platform vendor versus a cloud org owner. I wouldn't actually necessarily draw the line there. I've been both cloud org owner and a cloud vendor. I think the security is really a paramount issue in any of these situations. I think what really matters here is that whatever tool you have does to correlate this data does have appropriate security roles and responsibilities, so that you can provide different, with the same pool of data, different insights to different users, provide the right level of data access to the right level of users. Whether that's security, for just more concretely, I may want my security team to be the only ones who can see log information that pertains particularly to PCI compliance systems, right? Or I may be want the security team to be the only ones that can see information that may be indicative of intrusion, right? But that doesn't mean that I need to isolate that data in a completely separate security system. What it does mean is that whatever the correlation engines that you're using need to be able to tag that data and segregate it so that other users can't view it. You know, this is also important when you talk about how you're presenting to your business users and your technology users, because they're very different populations. And while you want to bring all that data together, sometimes it can be confusing or alarming to non-technical users. The same information that may be very useful to a sysadmin could be alarming to a salesperson, right? If you start showing the number of nodes that are flapping or whatever, may be completely normal system behavior. So in the same way, you need to ensure that you've designed your presentation, so the dashboards you're building for that audience and sharing the right data. So I think whether or not you're a cloud provider or cloud org owner, you've got to make sure that you've got the security in place to segregate your data once you've got it all together, and segregate it on a basis of the users that are viewing. So I hope that's answered the question that's being asked there.
Well, great. Well, thank you very much, Sean, Larry, and Chris, for a wonderful presentation today. And thank you to today's sponsor, Influx Data, for providing the DZone audience with a great webinar. Lastly, thank you to everyone who joined us today. We hope you learned something new that will help you in your developer career. Have a great day, and we'll see you next time.